Welcome, School of Computing students. Today, we explore online communities and cyber identities. Every time we interact online, we cast a distinct, measurable digital shadow. This diagram illustrates the architecture of modern online communities. Notice the three primary forms mapping out the network: social media, discussion forums, and gaming platforms. These are the built environments where users share information and build relationships. These platforms function as vast data ecosystems. Every connection generates continuous streams of interaction data. The systems track, aggregate, and store everything from a simple click to a complex multiplayer session. When data moves at this scale, specific vulnerabilities emerge. Those warnings popping up represent the ethical concerns embedded in these ecosystems, specifically the rapid spread of misinformation, critical privacy breaches, and coordinated harassment or cyberbullying. For computer scientists, understanding this platform architecture is the first step towards security. When billions of data points are aggregated into a single central hub, a single technical vulnerability in the data silo exposes the personal history and private interactions of every connected user. Moving from the macro network down to the individual user, this diagram shows how a single person projects themselves into distinct virtual environments. The same user might move from a professional virtual classroom directly into a metaverse platform or an online game. What you see here illustrates the separation between physical and digital existence. The cyber identity a user adopts online frequently differs from their real-world identity. These profiles generally take one of three forms. A real identity mirrors the physical person. An anonymous identity acts as a generic proxy to shield the user's data. A fake identity is actively disguised to appear as someone else entirely, serving as a tool for deception. Because virtual environments often feature internal economies where users trade real currency for digital goods, a deceptive identity can bypass social trust. By spoofing a trusted user, an attacker can siphon digital assets or reroute financial transactions to unverified accounts. The extreme malleability of these identities means that user authentication determines the safety of the entire community. If a system cannot reliably distinguish between a legitimate proxy and a fraudulent actor, it creates a loophole for identity theft. To manage this massive volume of complex identity data, platforms rely on artificial intelligence. This engine represents how profiles and interactions are systemically ingested for automation and rapid decision-making. We can observe this automation in recruitment systems. The AI rapidly filters thousands of incoming digital profiles, automatically sorting candidates into accepted and rejected categories far faster than a human evaluator. Look closely at the rejected path. If the initial training data contained historical prejudices, the system learns to apply AI bias. This results in the systematic rejection of qualified candidates based on flawed algorithmic weights rather than merit. Now consider how identity rules intersect with these automated systems. Analyze this case. Should users be allowed to remain anonymous on social media? Weigh the privacy benefits against the security risks and apply the ethical theories we've discussed to justify your opinion. When analyzing AI errors, the accountability question points back to the creators. These biases are rarely machine faults. They are the direct result of human-designed flaws in the data or the code itself. This grid maps vulnerabilities to consequences. First, platform architecture enables manipulation and widespread misinformation. Second, deceptive cyber identities execute identity theft, leading to fraud and privacy violations. Third, delegating decisions to AI recruitment systems impacts fairness, executing discrimination at scale. Here are your core takeaways. Platforms shape interaction. Identities are malleable. Virtual environments introduce ethical challenges. AI complicates accountability. Responsible digital behavior is essential. As students of the UUM School of Computing, you are coding the rules of human interaction. Security, privacy, and fairness of these digital spaces depend on design choices you make during development.